Assalamualaikum warahmatullahi wabarakatuh. My name is Muhammad Firdaus bin Mat Damizi, along with my friend Zulfadli bin Mat Nasri and Muhammad Ammar bin Shahnan. Today we will be talk about differentiation, and the application that we have choose is applied maximum and minimum problem. So, what is differentiation? In the simplest of terms, differentiation means breaking something into really small parts. Meanwhile, integration means taking those really small parts and gluing them into the right order. Therefore, it is easy to say that they are inverse of each other. Differentiation basically dealing with the process of dividing something to get track of the change, while integral is add or the piece together. Okay, so let's move on to the next session, which is application of differentiation. As we know, there are many applications of differentiation, such as related rate, which is rate of change, analysis of function 1, increase, decrease, and concavity, analysis of function 2, relative extrema, first and second derivative test, and applied maximum and minimum problem.
What is applied maximum and minimum problem? That is the method of to solve the problems by using those three applications that had been informed, such as related rate and analysis of function 1 and 2, which mean the first increase, decrease, and concavity, and the second is relative extremum first and second derivatives test.
So, when do we apply maximum and minimum problem? In occupation, such as businessmen, they always use applied maximum and minimum problem to find the value of stocks that they will need to get the profit and how much profit that they will gain from those stocks. Other than that, as a constructor, they also applied this application to calculate the area, volume and perimeter of their surrounding before start to construct to make sure or ensure the safety of the user and the other people.
Okay, the first situation is the daily profit P of an oil refinery is given by P equals to 8x minus 0.02 x squared, where x is the number of barrels of oil refined. The problem is how many barrels will give maximum profit and what is the maximum profit.
Okay, so let's start with the first question. The question said that the daily profit P of an oil refinery is given by P is equal to 8x minus 0.02 x power of 2, where x is the number of barrels of oil refined. How many barrels will give the maximum profit and what is the maximum profit? So, from the question, we know that the question asks us to find the value of the barrel that will give the maximum profit and what is the value of the maximum profit. So, we have been given that the value of P is 8x minus 0.02 x power of 2. So, to find the value of barrel, we must use first derivative test, which is dt over dx is equal to 0. So, we must differentiate the value of P, which is we will get 8 minus 0.04 x is equal to 0. So, from the question, we know that x is the number of barrels. So, x will get 8 over 0.04 is equal to 200 barrels.
Okay, to the next step.
we want to know this point is maximum or minimum value. So we differentiate this equation. That is called the second derivative method. So we differentiate this equation, which is, oh my bad. Okay. So differentiate x. So 0.04, which means less than 0. So we know that this point is maximum, max value. So how to find the point? We know that s, the value of s is 200. How to find p? So we substitute s into equation p. So sub x into p. So you substitute 200 minus 0.0200 power of 2. So 8 multiply with 200 equal to 1600, and then 0.02. 200 power of 2 is 40,000, and then 1600 minus this multiply is 800. So we get the point. The value of p is 800. So the max value, max point is 200 in the axis x and 800 to axis y. So that's all.
Second situation is a rectangular storage area is to be constructed along the side of a tall building. A security fence is required along the remaining three sides of the area. The problem is, what is the maximum area that can be enclosed with 800 meter of fencing?
Assalamualaikum. Today I want to show the calculation of this question. This is problems 2, and let's start. The question is, a rectangular storage area is to be constructed along the side of all the building. A security fence is required along the remaining three sides of the area. What is the maximum area that can be enclosed with 800 meter of fencing? Okay, so first of all we need to sketch like this, and we need to label this is x and this as a y. Okay, so from this we need to find that area. So as let's say the area is a equal to x y. Okay, so as we know 2x plus y, we will get 800, like the question given, 800 meter. So we need to write it 2x plus y equal to 800, and then we need a value of y, so we need to transfer 2x to the sides. So y 800 minus 2x, like that. So after that we need to put this into this, so we will get the area equation. So let's proceed. A equal to x, and y we put this value 800 minus 2x. So solve this. 800 x minus 2x square, like that. So after that we need to maximize the area, and we need to differentiate this like dA over dx equal to 0. So let's differentiate this. dA over dx equal to 800x 2x square. So we will get 800 minus 4x, like that. So we will get like this: dA over dx 800 minus 4x equal to 0, like that, like this. After we get the value of y, we need to transfer into this, and we will get the equation of the area, and then we need to differentiate it to maximize the area, like this. So next we will continue by Zulfadli. Thank you.
Okay, to the next step, we use the same method, second derivative, which means we differentiate this equation, so it becomes negative 4, which means less than 0 for all x. So we know this value is maximum. Okay, now we know the value of s is 200. How to find y? We have to substitute x into y to find the area. So substitute y. My bad. X equal to 0. A to 0 to 0 0 into y equals to 800 minus 2 multiplied with 200, which means 400. So 800 minus 400 equals to 400. So to find the area, we should use this equation. A area equal to xy. X which means 200 and y which means 400. So area is 2 multiplied with 4. So we get 8, 8, 80,000 meter square.
In conclusion, we can assume that by using applied maximum and minimum problem, we can solve any problems in our daily life with some method. For example, the derivative test, that which has two levels to find the value, either maximum or minimum value, such as in problems 1, that we can find the numbers of barrels needed and the profits gained from this method. The method is, we use the first derivative test to find the point when the slope is 0, and then use the second derivative test to find the value, either max or mean value. Other than that, beside from calculating profits, we can apply it in our daily lives, such as calculating the area of surrounding to make sure there are no errors when the works in progress. So this method is very useful exactly when we have to find some area or max mean point. So that's all. Thank you.